welcome back. Today we're going to do a short video showcasing our simulated clamp pressure within the nuLINK control. This video is going to show you the advantages of it, where to find it in the control, and how to apply it. Okay, we're going to start here with a coping cap that I have on the screen. We're not going to program this coping cap from start because that's going to be another video on how to do programming. As we continue with our series, we'll be showing about how to do various parts from the very beginning. All right, so let's get started. So we have here written our program, and I've already sequenced this program. And this program for a coping cap here has open hems on both ends. So that makes this part the perfect candidate to use the simulated clamp pressure. And what simulated clamp pressure is within our machine is that we can control where the clamping beam pinches down to hold the part. So the most efficient sequence for this part would be to bend this hem, kick it out, bend this hem, and then bend this 90 and this 90. We try to keep the part flat on the table so that we don't have to remove it for as many bends as we can in the part. And then in the very end, we'll flip it around and we'll put this hem underneath the lower beam and we'll make this bend, okay? And we'll do the same thing on this side. But if you clamp to a pressure, predetermined pressure like normal, okay, you will close up that hem, and we want to leave that hem open. All right, so let me advance here to our prepare screen, and I will run this part through and I'll show you what I mean. So we'll bend this hem, okay, we'll bend this hem, we'll bend the 90, we'll bend the 90. Now, here's what we're talking about. We'll take this hem and we're going to put it in the machine in order to make this kick. Well, if we clamp all the way down, we're going to close that hem. So what we can program the machine to do from right here is we can make the machine clamp lighter, okay? And it will pinch that hem just enough to hold it so that it can be bent, but it won't crush it, all right? So let's find where that is. Simulated clamp pressure. So if we open our program line for that 45-degree bend here, and we scroll here where it says clamp pressure. We open the window for clamp pressure. Right now, the machine is set to clamp down at 10% of its capacity to run this part, which is pretty normal. But we don't want to do that. If 10% of that pressure will crush that hem. So we're going to assign our simulated clamping pressure, all right? And we're going to give it a value. And what I have found is 0.160 is a good value to assign to that for clamping. Go ahead and show the other hem. Now it's flipped around. We're on the last kick here. Okay. And sorry, pressure again, 10%. And we're going to assign that. And we're going to clamp it to 0.160. So now when I run this part, we're going to pre-bend our hems. All right. Let's go back to the hems. Pre-bend these hems and we'll smash them down, okay? But we're not going to smash them all the way down. Let's go to the hem. And I probably should have said this earlier. When you're in the hem, all right, you're going to press that hem to fairly open, all right, 0.2. We're going to leave that hem about 1/4 inch open because our hem, when we press it, needs to be more open than our simulated clamp pressure. Otherwise, you're not going to get pressure when you come to step down on top of it. Sorry, that's not where I need to be. Here. Okay, there we go. Goes 0.2. So when we make the initial hem, we're going to clamp it down to about 0.2. Okay, it needs to be bigger than the 0.160 that we're going to step on later, okay? Otherwise, it won't hold the part. Okay? So we're going to pre-bend a hem. To do the second hem, we're going to run the part. Now we get here. We've assigned that clamp pressure of 0.160. Obviously, this will be sitting above the line here. The graphic doesn't show it, but that's where it'll be sitting. And we'll clamp down onto this part and we'll hold it without crushing so that we can make this bend okay, in this fashion here. So what you will actually have on your machine is this surface will be on the lower beam, and this top clamping beam will come and touch the top of this, and it'll take that opening of 0.2 and it'll squeeze it just a little bit more so that this bend can be made. But then when you release it, it'll still be, the hem will still be open enough that you can use it for your clips, right? And then we'll spin that part around, and we'll do the same thing on the other side. So just to recap a little bit, we have a function within our nuLINK control called simulated clamp pressure. The purpose of this function is so that you can clamp on open hems without crushing them. Okay. A secondary purpose is if you have some material that's relatively sensitive, copper, things of that nature, and 0% clamp pressure on the machine, which is still a lot of pressure, right? Because 0 was just our baseline for the amount of pressure it takes to hold a part. If you need to clamp a little bit lighter than that, right, you can assign simulated clamp pressure where you don't clamp down quite as hard. Another use for simulated clamp pressure, or if people are bending like the plexiglass or these, light fixture covers or things of that nature where you can't clamp so hard, you could use simulated clamp pressure and you won't push so hard down. Now, when you're using simulated clamp pressure and you're clamping very lightly, okay, you should expect to have to add a little more angle correction with this, okay? So this concludes my video. Hopefully it was informative for you, and have a nice day.